So I'm going to look at some questions involving arithmetic and geometric progressions, or sequences. The purpose of these questions is to provide you with the opportunity to apply what you have learned in the previous 3 videos. The links to those videos are in the description below. So I'm going to go through 5 questions and I'm going to show them up front so that if you want to do these questions before I go through the answers, then you can do so. So as I show each question, you can pause the video, have a go at the question, and then when you've done that question, press play to get the next question. So here's question 1. Here's question 2. Here's question 3. And here's question 4. And here's question 5. So let's go through question 1. The sequence starts 2, 6, 10, 14 and 18. Part A is, what are the next 2 terms in the sequence? Well, we can see that we're adding 4 each time. So the next term in the sequence is going to be 18 add 4, which is equal to 22. And the next term after this is going to be 22 add 4, which is equal to 26. So the next 2 terms are 22 and 26. Part B says, what is the nth term of the sequence? Well, there are 2 ways of doing this. The first way is to think of the formula that we looked at in the previous video, and that is the nth term is equal to a add n subtract 1 or multiplied by d, where a is the first term and d is the difference. So we can set it out like this. The nth term is equal to 2 add n minus 1 in brackets multiplied by 4, which is then equal to 2 add 4n subtract 4, which is equal to 4n subtract 2. What I would do is I'm thinking, well, we're adding 4 each time, so it's going to be the 4 times table. So the nth term is going to have 4n. I now need to think of how do I get from my 4 times table to my sequence, and we can see that we're having to subtract 2 each time. So our nth term is going to be 4n subtract 2. And then finally it says, what is the 100th term of the sequence? So the 100th term is going to be 4 multiplied by 100 subtract 2, which is equal to 398. Question 2. Write down the first 5 terms in the sequence whose nth term is 3n add 1. So the nth term has got 3n in it, so I'm thinking of the 3 times table. So our first term is going to be 3 multiplied by 1 add 1, which of course is going to equal 4. Our second term is going to be 4 add 3, which is equal to 7. The third term is going to be 7 add 3, which is equal to 10. The fourth term is going to be 10 add 3, which is equal to 13. And the fifth term is going to be 13 add 3, which is equal to 16. Part B asks, 40 is a term in this sequence. What term is it? So we need to work out what n is. So we know that 40 is equal to 3n add 1. So 3n must equal 39, because 39 add 1 is equal to 40. So 3n is equal to 39, which means that n is equal to 13. So 40 is the 13th term in the sequence. Question 3. A sequence starts 3, 12, 48, 192, 768. Part A. What kind of sequence is this? Well, we can see that we are multiplying by 4 each time to generate the next term in the sequence. So this is a geometric sequence. For part B, write an expression for the nth term of the sequence. As we covered this in the previous video, the nth term for a geometric sequence is a multiplied by r to the power of n subtract 1, where a is the first term and r is the multiplier. So the first term in the sequence is 3 and our multiplier is 4. So the nth term is equal to 3 multiplied by 4 to the power of n subtract 1. And part C asks, what is the 10th term of the sequence? So the 10th term is equal to 3 multiplied by 4 to the power of 10 subtract 1, which is 3 multiplied by 4 to the power of 9. And that works out at 3 multiplied by 262,144. So our final answer is 786,432. And that's our 10th term. Question 4. A sequence is generated by using the rule add 3 to the previous term. The second term in the sequence is 8. Part A. What is the nth term of the sequence? Well, if we're adding 3 each time, and I'm thinking of the 3 times table here, the first term must be 8 subtract 3, which is equal to 5. Again, we have two choices of how we find the nth term for this sequence. It's an arithmetic progression. So, we could use the formula, which is a add n subtract 1 multiplied by d. So the nth term would be 5, which is the first term, add open brackets n subtract 1 close bracket multiplied by 3, which is the difference. So the nth term would be 5 add 3n subtract 3, and so the nth term would be 3n add 2. Alternatively, and this is what's going on in my head, as I say, I'm thinking of the 3 times table. So I know our nth term is going to have 3n in it. So here's the 3 times table, and here's our sequence. And to get from our 3 times table to the sequence, I'm adding 2 each time. So our nth term is 3n add 2. Part B. What is the 50th term in the sequence? Well, the 50th term is going to be 3 multiplied by 50 add 2, which is equal to 150 add 2, which is equal to 152. Part C asks, is 29 a term in this sequence? Explain why. Well, if 29 is a term in the sequence, then n has to be a natural number. That is 1, 2, 3, 4, 5. Remember that we are finding the first, the second, the third, the fourth, the fifth, the sixth term in our sequence. You can't have a fifth and a half term in a sequence. Let's write down 29 is equal to 3n add 2. This means that 3n must equal 27, because 27 add 2 is equal to 29. So n must equal 9. So the answer is yes. 29 is the 9th term in the sequence. Let's just say the question had asked, is 30 a term in the sequence? Well, we then put in 30 is equal to 3n add 2. This means that 3n would equal 28. And we'd end up with n is equal to 9 and 1/3. Well, you can't have a 9th and a 3rd of a term. N has to be a natural number, so 30 isn't a term in the sequence. And here's the final question. What are the first 5 terms in the sequence 1024 over 2 to the power of n subtract 1? Now you could do this one of 2 ways. The first way would be to plug in values for n. So for the first term, n would equal 1, which would give us 1024 divided by 2 to the power of 0, and that would equal 1024 divided by 1, which is 1024. For the second term, n would equal 2, so we have 1024 divided by 2 to the power of 2 subtract 1, which is equal to 512. The third term, n is equal to 3, so we have 1024 divided by 2 to the power of 3 subtract 1, so we end up with 256. And then for the fourth term, we have n is equal to 4, so we have 1024 divided by 2 to the power of 4 subtract 1, and that is equal to 128. And for the fifth term, we have 1024 divided by 2 to the power of 5 subtract 1, and that is equal to 64. So you could have done it that way. However, if you remember from the previous video, this is a geometric sequence where the terms are being divided by the same amount. I'm thinking of the nth term is equal to a divided by r to the power of n subtract 1, where a will be 1024 and r is equal to 2. So we are dividing by 2 each time. So if the first term is 1024, the second term will be 1024 divided by 2, which is equal to 512. The third term will be 512 divided by 2, which is equal to 256. The fourth term will be 256 divided by 2, which is equal to 128. And the fifth term will be 128 divided by 2, which is equal to 64, which coincides with what we have over here. Either way is correct. So there are some questions around arithmetic and geometric progressions. If you had any problems, then go back over the previous videos that I covered on this topic. Everything that I talk about there should help you with these questions. But I hope you found the video helpful. If you did, don't forget to like and subscribe. And thank you for watching.